Tell me about a time you improved application performance introduction. This is one of the most common behavioral interview questions for software developers, especially for backend, Java, full stack, and senior developer roles. Interviewers ask this question to understand how you identify performance bottlenecks, how you analyze slow systems, how you use logs, metrics, and monitoring tools, how you optimize database queries, how you improve API response time, how you reduce system load, how you validate performance improvements, how you measure business impact. This question is especially important for Java developers, backend developers, core developers, cloud developers, production support developers, team leads. The best way to answer this question is by using the STAR method. STAR means S, situation, explain the background. T, task, explain your responsibility. A, action, explain what you personally did. R, result, explain the final outcome. A good interview answer usually spends 10% situation, 10% task, 60% action, 20% result. The most important part is the action section because interviewers want to know exactly how you improved performance. Question: tell me about a time you improved application performance. Example 1. Slow API response time situation. In one of our production applications, users started experiencing slow response times during peak business hours. One important API that usually responded in under 1 second started taking more than 10 seconds. Task: as a backend developer, I was responsible for identifying the performance bottleneck and improving the API response time without affecting existing functionality. Action: I started by reviewing application logs, monitoring dashboards, and API response time metrics. I compared the API behavior during normal traffic and peak traffic. After investigation, I found that most of the delay was coming from the database layer. I reviewed the database execution plan and found that one query was performing a full table scan on a large table. The query was also joining multiple tables and fetching more columns than required. To improve performance, I worked with the database team to add proper indexes on frequently filtered columns. I also optimized the query by check, removing unnecessary joins, check, selecting only required fields, adding pagination, reducing repeated database calls, caching frequently accessed data. After making the changes, I ran performance tests using production-like data volume. Result: the average API response time improved from more than 10 seconds to under 2 seconds. The system handled peak traffic more smoothly. Customer complaints related to slow response time dropped significantly. The same approach was later used by the team for other performance optimization work. Why this answer works? This answer is strong because it shows performance analysis, database optimization, execution plan review, caching, measurable result, production impact. Example 2. Database query optimization situation. A reporting page in our application was taking too long to load. Business users had to wait more than 30 seconds to view reports, which affected their daily workflow. Task: I was responsible for improving the report loading time while keeping the report data accurate. Action: I started by checking browser network timing, API response time, backend logs, and database query execution time. I found that the backend API was slow because the report query was joining several large tables. The query also calculated totals dynamically every time the report page was loaded. I reviewed the SQL execution plan and found missing indexes on important filter columns. To improve performance, I added indexes with help from the database team. I also optimized the query by reducing unnecessary joins, moving repeated calculations to a pre-computed summary table, filtering data earlier in the query, using pagination for large result sets, avoiding select star, returning only required columns. I validated the result by comparing the optimized report output with the original report output. Result: the report loading time improved from more than 30 seconds to around 5 seconds. Business users were able to access reports faster. The optimization also reduced database load during business hours. Why this answer works? This answer is good because it shows SQL tuning, execution plan analysis, report performance improvement, data accuracy validation, business user impact. Example 3. Adding caching for frequently requested data situation. Our application had a lookup API that was called frequently by multiple screens. The lookup data did not change often, but every request was going to the database. During high traffic, this created unnecessary database load and increased response time. Task. I was responsible for improving the performance of the lookup API and reducing database calls. Action. I first analyzed API usage metrics and database query frequency. I found that the same lookup data was being requested repeatedly throughout the day. Since the data changed rarely, I proposed adding caching. I implemented caching for frequently requested lookup data using a controlled cache strategy. I added cache key design, time-based expiration, maximum cache size, cache invalidation rules, fallback to database if cache missed, monitoring for cache hit rate. I also made sure the cache did not return stale data for business-critical updates. To validate the improvement, I compared API response time and database query count before and after caching. Result: the lookup API response time improved significantly. Database calls for lookup data were reduced by more than 70%. The application became more responsive, and database load during peak hours decreased. Why this answer works? This answer is strong because it shows caching strategy, database load reduction, performance measurement, safe cache invalidation, production scalability. Example 4. Batch job performance improvement situation. A nightly batch job was taking more than 6 hours to complete. This delayed downstream reports and created problems for business users the next morning. Task. I was responsible for improving the batch job execution time without changing the business rules. Action. I started by reviewing batch logs, step execution time, database queries, and file processing logic. I found that the batch job was processing records one by one and making repeated database calls inside a loop. This created thousands of unnecessary database round trips. To improve performance, I redesigned the batch job to use chunk-based processing. I also introduced batch inserts and batch updates instead of processing each record individually. I made several improvements. Increased chunk size carefully, reduced database round trips, cached repeated lookup data, added indexes for frequently filtered columns, improved logging for each batch step, optimized commit frequency, tested with production-like data volume. Result: the batch job execution time was reduced from more than 6 hours to under 2 hours. Downstream reports were ready earlier. The business team was able to start morning operations on time. The improved batch design also made future troubleshooting easier. Why this answer works? This answer is strong because it shows batch processing knowledge, database optimization, chunk processing, production data handling, measurable improvement, business impact. Example 5. Reducing memory usage in Java application situation. One of our Java microservices had high memory usage during peak traffic. The service did not always crash, but it triggered memory alerts and sometimes slowed down other processes running in the same environment. Task. I was responsible for analyzing the memory usage and improving application stability. Action. I started by reviewing memory metrics, garbage collection logs, and heap usage trends. I noticed that memory usage increased when large requests were processed. After profiling the application, I found that the service was loading large datasets into memory before processing them. This was unnecessary because the data could be processed in smaller chunks. To improve performance, I changed the implementation to use streaming and pagination instead of loading everything at once. I also reviewed object creation and removed unnecessary temporary objects. The improvements included processing data in smaller chunks, Click using pagination for large datasets. Click avoiding loading full result sets into memory. Click reducing unnecessary object creation. Click reviewing garbage collection behavior. Click adding memory usage monitoring. Result: memory usage became more stable during peak traffic. The number of memory alerts dropped significantly. The service became more reliable and handled large requests more efficiently. Why this answer works? This answer is good because it shows: check JVM performance analysis, check memory optimization, check large data handling, check profiling, production stability improvement. Example 6. Front-end page load performance situation. A customer-facing dashboard page was loading slowly. Users had to wait several seconds before the page became usable, especially when the dashboard had many widgets. Task: as a full-stack developer, I was responsible for improving the page load experience without removing important dashboard features. Action: I started by analyzing browser developer tools, network requests, API response times, and front-end rendering behavior. I found that the page was calling multiple APIs sequentially, and some large JavaScript bundles were slowing down the initial load. I worked on both front-end and back-end improvements. On the front end, I improved performance by: check loading non-critical widgets lazily, reducing unnecessary re-renders, splitting large JavaScript bundles, showing loading placeholders, avoiding repeated API calls. On the back end, I optimized slow APIs and added pagination for large datasets. I also worked with QA to test the dashboard across different data sizes and browser conditions. Result: the dashboard became usable much faster. Initial page load time improved significantly. Users had a better experience because important information appeared earlier instead of waiting for the full page to load. Why this answer works? This answer is strong for full-stack roles because it shows: check front-end performance analysis, check API optimization, check lazy loading, check user experience improvement, check full-stack ownership. Example 7. Reducing external API latency impact situation. Our application depended on an external service for customer verification. During peak hours, the external service became slow, which increased response time in our application. Task: I was responsible for improving our application performance and reducing the impact of the slow external dependency. Action: I started by reviewing API latency metrics and timeout logs. I found that our application was waiting too long for the external service and blocking request processing. To improve performance, I updated timeout settings and added asynchronous processing for non-critical verification steps. I also implemented a circuit breaker pattern so the application would stop repeatedly calling the external service when it was unhealthy. For repeated verification requests, I cached safe verification results for a limited time. The improvements included: check better timeout configuration, check retry only for safe failures, circuit breaker pattern, check asynchronous processing, limited caching, monitoring external API latency. Result: application response time became more stable even when the external service was slow. Timeout-related errors reduced significantly. The system handled third-party slowness more gracefully and gave users a better experience. Why this answer works? This answer is strong because it shows: external API performance handling, external resilience design, X timeout management, circuit breaker pattern, X async processing, X user impact reduction. Example 8. Improving search performance situation. Our application had a search feature that became slow as the amount of data increased. Users were waiting too long to get search results, especially when using filters. Task: I was responsible for improving search performance while keeping the search results accurate. Action: I started by analyzing search API logs, query execution time, and common user search patterns. I found that the search query was using inefficient wildcard searches and scanning too many records. The filters were also being applied late in the query, which increased processing time. To improve performance, I optimized the search query and added proper indexing. I also changed the search flow, so filters were applied earlier. The improvements included adding indexes on searchable fields, applying filters earlier, limiting result size, adding pagination, optimizing sorting logic, caching common search filters, reviewing search result accuracy. For large search use cases, I also suggested using a dedicated search engine as a future enhancement. Result: search response time improved significantly. Users were able to get results faster. The database load caused by search queries was reduced, and the application became more scalable. Why this answer works? This answer is good because it shows search optimization, indexing, query tuning, pagination, scalability thinking, user experience improvement. Best short answer version. If you need a short interview answer, you can say, in one of my production applications, an important API became slow during peak business hours. The response time increased from under 1 second to more than 10 seconds. I was responsible for identifying the bottleneck and improving performance without affecting existing functionality. I started by reviewing logs, monitoring dashboards, and database execution plans. I found that the delay was coming from a database query that was doing a full table scan on a large table. The query also had unnecessary joins and fetched more data than required. I worked with the database team to add proper indexes and rewrote the query to fetch only required fields. I also added caching for frequently requested data and created performance tests using production-like data. As a result, the API response time improved from more than 10 seconds to under 2 seconds. The application handled peak traffic better, and customer complaints related to slowness dropped significantly. Common mistakes to avoid. 1. Saying only, I made it faster. Bad answer. I optimized the application and made it faster. Better answer. Explain what was slow, how you found the bottleneck, what you changed, and how much performance improved. 2. No metrics. Bad answer. The API became much better. Better answer. Response time improved from more than 10 seconds to under 2 seconds. 3. Not explaining root cause. Bad answer. The application was slow because of performance issues. Better answer. The root cause was a database query doing a full table scan on a large table. 4. Ignoring validation. Bad answer. I changed the query and deployed it. Better answer. I validated the optimized query with production-like data and compared the results with the original output. 5. Overcomplicating the answer. Do not explain every technical detail. Focus on, problem, investigation, root cause, solution, result. Best practices for answering this question. Click. Use the STAR method. Choose a real performance issue. Mention the user or business impact. Explain how you measured performance. Identify the bottleneck clearly. Explain your optimization steps. Use numbers in the result. Mention testing and validation. Mention monitoring after deployment. Keep the answer around 2 minutes. What interviewers are looking for. Interviewers want to see whether you can, identify bottlenecks, use logs and metrics, analyze database performance, understand caching, optimize backend logic, improve front-end loading when needed, test performance safely, measure improvement, think about scalability. For senior roles, they also want to see ownership, production thinking, architecture awareness, mentoring, long-term improvement, reusable optimization approach. Strong words to use in your answer. You can use words like yes, analyzed, measured, identified, optimized, reduced, improved, cached, indexed, profiled, validated, monitored, scaled. Example: I analyzed the metrics, identified the database bottleneck, optimized the query, added caching, validated the change with performance tests, and monitored production after deployment. Performance areas you can mention. Depending on your real experience, you can talk about API response time, database queries, indexing, caching, batch jobs, memory usage, garbage collection, front-end loading, search performance, external API latency, network calls, file processing, asynchronous processing, pagination, connection pools, thread pools. Final summary. Tell me about a time you improved application performance is a very important interview question for software developers. The best answer should include what was slow, why it mattered, your responsibility, how you investigated, what bottleneck you found, what changes you made, how you validated the fix, measurable results. Good examples include: check, slow API response time, database query optimization, adding caching, batch job performance improvement, reducing memory usage, front-end page load improvement, reducing external API latency impact, improving search performance. The strongest answers are specific, structured, measurable, and focused on your actions.